Building an HO scale flour mill was bound to be a good challenge because of the moving parts that would be involved in a working model. I chose to build a mill from the late 1800s to the early 1900s before things became too mechanized. My research included the basics of a water-powered mill and how wheat or corn was ground into flour. While this model isn't a prototype, it is representative of the flour mills from that era. Wheat or corn is taken to the mill either on horse-drawn wagons or railcars. In the model I built, I assumed that bags of unground wheat or corn would arrive by railcar or boxcars of the era, ground into flour, and then shipped out on boxcars. Arriving bags would be hoisted up to the top floor, where the grain would be dumped into a hopper. From there, it would fall through a chute to the stone grinder on the floor below. As the wheat or corn is ground, it sifts out between the millstones and then falls through another chute to the ground floor where it is bagged and ready to ship. The mill is labor-intensive, with workers filling the hopper, operating the millstone, filling the bags with flour, and loading and unloading the freight cars. Mills of this era operated mainly on water power. Usually channeled water turns a water wheel, which turns the millstones, grinding the grain into flour. Changing the angle of the turning shafts requires some clever work with gears that I printed from previously designed parts I found on thingiverse.com. Because I wanted the mill to operate, I had to decide whether to try to make the water wheel turn by water, pumped through the channel, or to install a motor to drive the mechanism. After some thought, I decided that I didn't want water splashing all over the model, and the plumbing would be difficult. I elected to use a slow-turning 12-volt motor that's operated by a separate switch on the back of the model. That way the lights could be on, and the motor could be operated separately because it's noisy. The motor was mounted under the model and attached directly to the vertical shaft that goes up through the floors and ultimately turns the water wheel and the grinder. This is the reason that the base of the model sits higher than previous things that I built. The ground floor was going to be brick and the upper floors were going to be scale lumber. The floor was designed to accommodate the main gear that is turned by the water wheel and was made from 3D printed resin. A suitable brick pattern was found on Thingiverse and scaled to HO scale in the CAD program. There would be an office and an entrance on one side of the mill, and that was printed in one piece since it wasn't very big. The main ground floor was printed in 3 different pieces because it was too big to fit on the printer's build plate. The door openings were designed with supports for the horizontal brick that were removed after printing. The windows were printed in place. Holes were designed in the water channel and mill wall for the horizontal shaft of the water wheel. It was important that all of these lined up correctly and at the correct height above the ground. After gluing the components of the ground floor together, including the office, I built the second-story floor, walls, and third-story floor. I wanted the interior of the model to be visible, and I eventually decided to make the roof removable. The roof is 3D printed and then covered with a roof tile pattern that I painted a slate gray. It ended up fitting perfectly on the side walls of the mill. Aligning the gears with the stone grinder was a bit tricky because it had to be supported in all directions so that it would stay in place. I used some 3D printed supports for this. The hopper and the stone grinder were 3D printed, as was the lighted stove and the ground floor. The loading platform is HO scale lumber. The figures of the workers came unpainted and I hand painted all of them. There was a desk, counter, and small wood-burning stove in the office. All of the cargo was 3D printed and painted. 2 boxcars were scratch-built representative of the early 1900s. The chassis is 3D printed and the body is HO scale lumber. The cargo is 3D printed. Couplers and trucks are by Katie. The sign saying Holton's is a decal that I printed and mounted on a white balsa. The grounds were formed out of plaster and landscape. The water to the water wheel comes in via pipe and exits that way, with water being formed out of Mod Podge and Woodland Scenic's water feature. A couple notes on the photography and videography of the model. I used a Nikon D3200 at f/18 and a 1-second exposure for the still images. The video was obtained with a borescope, which I handheld, hence the shakiness of it. It's very tiny and difficult to maneuver. The background for the stills was done with a sky replacement feature in Photoshop. I wanted to represent the model with the lights on, creating a mood of early evening. Thank you for watching, and please subscribe to the channel for more videos on HO scale model building.